Greetings and welcome. We are talking about trigonometric ratios in right triangles. We're taking a look at page 288, our homework. And here's problem 12. They asked us to find sine, cosine, and tangent from angle A's perspective for this problem. So sine A, cosine A, and tan A, all from angle A's perspective, right? And in order to answer some of those questions, I'm actually going to have to find out what the length of side B is here, right? Little b is opposite of big B. And that looks like a Pythagorean Theorem question right there. Looks like. So I'm going to use some classic a squared plus b squared equals c squared and just solve that real quick. So I would have 12 squared plus b squared equals 40 squared. 12 squared is 144 plus b squared equals, let's see, what's this going to be, 1600? Is that right? Mm-hmm. So subtract 144 from both sides, and what's that going to be? 1456. Technically, no. No, those ones don't matter. So 1600 minus. Yep, and then square root that, both sides. I wonder, is there a perfect square that goes into 1456? No, it wasn't. It was so weird. So I can't. No. It's not. Oh, it is divisible by 4. And then is that divisible by? Oh, 16 goes into it. Yeah. Yeah, so if I root both sides. Technically, I'd plus or minus for the algebra's sake, but since I'm talking about a positive length, I don't have to worry about that right now. So I would say that b is equal to, it turns out the square root of 16 goes into that 91 times. I was looking for perfect squares that divided into it is what I was specifically targeting. The square root of 16 is 4, and the square root of 91, I believe, 91... Is 91 even prime? Might be. I don't know. Could be. So, so there's the value of b. All right. So if I want to find the sine of A is from SOHCAHTOA, right? SOHCAHTOA. Sine is the ratio of the opposite over the adjacent. So the opposite leg is 12. No, opposite over hypotenuse, that's an h. So 12 over 40 would be the value of A. And that reduces, 4 goes into both of those? 3/10 would be the ratio for sine of A. Cosine of A is going to be whatever B is over 40, so that's going to be 4 roots of 91 over 40. 4 and 40 can cancel out partially, so that's going to be the square root of 91 over 10. Is that how the book listed the answer? Nice. Wow. I like how they also reduced their radical. And tan of A is going to be opposite over adjacent, so 12 over B. So 12 over 4 roots of 91. Well, 4 and 12 I can partially cancel, both by 4, so that's going to be 3 over the square root of 91. And then I would, in order to get rid of the radical in the denominator, I would have to multiply by rad 91 over rad 91, and I'd get 3 rad 91s over 91, and 3 and 91 cannot cancel. So that's how I do that. It's all about ratios, and then there's the little bit of work with radicals that you might need to remember how to do, and not leaving radicals in the denominator, sort of thing. So there we go. So those are the values of those ratios for this particular angle. Right? Let's take a look at 13. It says the slope of a line is the ratio of change of y to change in x. Name the trigonometric ratio of theta that equals the slope of line n. I guess they didn't really label where theta was in this. So theta would be this angle here, right there. And let's see, I've got change in y, change in x. So change in y is the opposite from that perspective, and change in x is the adjacent in that perspective. And which trig function relates the opposite to adjacent? Tangent. right? So tangent is the answer because tan theta relates y over x in this case. All right, so I think in pre-calculus we'll actually look at writing equations of lines and such based off of a different form, polar form, where it's based off of a radius and an angle. And in order to convert from polar form back into Cartesian coordinates, there's a conversion between your slope and theta using this relationship here. So I could also equal that to m. So that fact is going to be helpful in the future. Let's see, here's problem 16. The directions here said, it's got the directions in itself. If secant theta is equal to 5/9, find cosine of theta. Now, secant was the reciprocal function for cosine. And that means cosine is also the reciprocal of secant. All right, flipping something and flipping it again is going to bring me back to kind of the start. So it's either way, it's the same process. You're just flipping the fraction. So cosine of theta is just going to equal the reciprocal of that, which is 9/5. And that's all you have to do to figure that. That's 1.8. Yep. Yep. So 9/5 is 1.8. So that's all you have to do for that, is know which functions are reciprocal functions of one another. Eventually we'll actually have even more complicated steps, like, for instance, what if I gave you sine theta and wanted you to find cotangent theta? All right, and you'd have to find some way to bridge the gap between them, and we'll do that eventually. And let's see, lastly, for problem 22, it looks like I've got my two legs labeled, but I have to find the value of the hypotenuse. So I'm going to say 9 squared plus the square root of 7 squared equals c squared. 81 plus 7 equals c squared. C squared is going to equal 88. And then I'd root both sides. And I technically could plus or minus there, but I won't since I know where I'm going. So c is going to equal, well, I believe 4 goes into 88 22 times. So that's the square root of 4 times the square root of 22. And I'm choosing 4 because it's the largest perfect square I could think of that was a factor of 88, right? So that's going to be 2 roots of 22. All right, so there's the value of c, 2 roots of 22. So now if I want to find the trig ratios, sine of, let's see, they actually specify from angle r. Okay, so sine of r, cosine r, tan r, and then we'll do the reciprocal functions. Reciprocal of sine was cosecant. Reciprocal of cosine was secant. And the reciprocal of tangent is cotangent. So let's see if we can figure these out. So for sine, that's opposite over hypotenuse. The opposite is square root of 7. The hypotenuse is root 22. So that's root 7 over 2 roots of 22. I'd have to multiply by root 22 over root 22. 7 times 22. 154. That's the square root of 154 over, and in the denominator, root 22 times root 22 is 22, and then multiply by that 2 is 44. Square root of 154, is there a perfect square that goes into that? 4 doesn't. I'm guessing 9, no. I'm guessing not. I'm thinking that works out just fine. Yep, and the book confirms with this answer, so I'm guessing that we're good on that. For cosine, that would be adjacent over hypotenuse. The adjacent is 9, the hypotenuse is 2 roots of 22, so that would be 9 over 2 roots of 22. I'd multiply top and bottom by rad 22, and I'd get 9 rad 22 over rad 22 times rad 22 is 22, multiplied by this other 2 is 44. And 9 and 44 don't cancel. Now question, can I reduce the 22 and the 44? I cannot, because one is in a radical and the other isn't. If they actually were both in radicals, you could cancel them like a normal fraction if their radicals have the same index. So for instance, if this was 7 and 21, I actually could have reduced that before I dealt with it, if I'd wanted to. For tan r, that's going to be opposite over adjacent, so that's just root 7 over 9. No radical, nothing to reduce, so we're good. Now cosecant is the reciprocal of sine, so I'm going to reciprocate this and then simplify it. So that would have been 2 roots of 22 over root 7. Or I could have also thought about it as hypotenuse over opposite, and I would have gotten to the same spot. Then I multiply top and bottom by rad 7, and I'd have 2 rads of 154 over rad 7. Rad 7 is just 7. And for secant r, that would be hypotenuse over adjacent, or it's just the reciprocal of the cosine of r. So that's going to be 2 roots of 22 over 9. And I don't actually have to modify anything there. That's fully simplified. And for cotangent r, that would be adjacent over opposite. So that's 9 over root 7. I'd multiply top and bottom by rad 7. 9 rad 7 over 7. And nothing reduces there. So the way I remember most of those ratios is SOHCAHTOA for the classic 3 trigonometric ratios, and their buddies, the reciprocal functions, would be CHO, CHA, COW. Right, for cosecant and cotangent being those C's there. And this, of course, is not sine. That would just be secant. Right? So all it does is notice I just switch those, right, because they're reciprocals. So thanks for watching, Internet friends. Have a great day. Bye-bye.